Hello and welcome to this presentation on Agile Systems Engineering. My name is Christoph Ebert. I'm the Managing Director of Vector Consulting, and today with me is Frank Kirschke-Biller of Volkswagen, and we will present on Agile Systems Engineering. First, we were going to introduce ourselves, then we motivate the topic, and then we will show some practical results, and we will finalize with some conclusions from our practical experience. And that means at this point, I want to hand over directly to Frank.
Yeah, welcome as well from my side. Frank Kirschke-Biller speaking here. I'm working as a senior manager at VW right now and leading the E/E process methods and tool team, including several other aspects like functional safety. Before I was engaged at Ford for best of 20 years in various positions, for example, as manager of global core software processes, and appreciate being here today.
And well, my name is Christoph Ebert. I manage already. I work with Vector Consulting, responsible for the consulting activities of Vector worldwide. And aside that, also active with teaching, because it's helpful to also give a practical view to the engineers of tomorrow.
Yeah, so let's start with motivating why we are talking about agile system engineering. In the automotive industry, there is a tremendous change ongoing since many, many years. So from a situation where the amount of electrical features and functions in the car was rather low, we are now in a world where the car is a real high-tech product full of computers and software. And that's to deliver what we would summarize as smart mobility, with a lot of functionality in the car, driver assistance stuff, linked to the internet, cloud-based functions. As a result of that, the software growth is tremendous, and the complexity of software and as well of the electrical architectures below is tremendous. We have seen over the last years a growth from a few ECUs up to 120, I think, in the top. We are seeing more complex links, car to car, car to infrastructure, all the cloud-based services, and very important aspects like functional safety and cyber security are playing an enormous role. To be able to manage that level of complexity, we believe that systems engineering is one way to go. That's a good way to structure interfaces, to get a deep and full understanding of the system structure and behavior. But on the other hand, as you can see in the graph on the top right side, we are in an area where new technologies like driver assisting autonomous vehicles are more and more advanced technologies where we have no historical knowledge, where we are in a more and more uncertain area. So we need to cope with changes coming out of that level of uncertainty and manage those, where agility is very helpful. And as software is the key enabler of the vehicle functionality, we would like to benefit from the best practices in software engineering, where Agile is one of them. So that's in a nutshell why we are talking today about Agile systems engineering. And Christoph can give you more insights from the market here.
And this is a result from a recent survey, which we have been doing. We do that every year with clients. We ask, amongst other questions, what are the short-term challenges, what are the long-term challenges? And the interesting evolution this year is that we see competence in the upper right corner. It was moving from the left to the right. Innovation changed position with competence. But what we see in this upper right is what we call a new magic triangle. And it relates to the new normal. Why? Because we used to have this classic magic triangle, which you learn in project management, which is cost, quality, time, cannot be individually optimized. And today we see cost, complexity, quality. This is just one dimension, but we have a big need to have the right competence, especially software competence and systems competences. And we have also a huge market pressure and global competition for innovation. And this can easily lead into a vicious circle, a downward circle, for instance, in the need of innovation and the lack of competences with this trap of cost and complexity could end up in a situation where we don't have enough good quality innovation, and that is a severe risk. And that brings us into systems engineering, because systems engineering allows for two things: to see on the one side the combination of the different aspects which build the functionality, but on the other side also to be able to make trade-off decisions in an informed way. And often what we see in practice is ad hoc trade-off decisions. Now, why is the need for Agile? Well, this relates also to this previous picture, because we are in this cost complexity trap. And the answer to the cost complexity trap, that is what we all know since 20 years, we have to work in an Agile mode. So on the one side, we have the need to work more systems oriented. On the other side, we need to work in an Agile mode, and that together brings us into Agile systems engineering. And that's summarized here. We have an evolution which was collocated primarily here software, here hardware, into multi-location ecosystems, different type of teams, system of systems, high complexity, software as a service. All this evolution means that we need to have this systems perspective. The days are gone where we can really collocate functions in the ECU. We today talk about distributed functionality, distributed IT, both in the product that is embedded to the car, but also in the cloud. And this is to be managed with systems engineering. And if we look into the dimension of Agile, we summarize this in this picture here. We have 5 basic value in Agile. This is the empowerment, it's value orientation, reduce waste, optimize the value streams, and continuously improve. Now that means if we translate that into application domains, and that is an experience from our Agile transformation project, we have to work with people. That's key in Agile. And people means not that everybody is doing what they like to do. That is a common misperception in Agile. Agile needs planning. That's, by the way, why we typically don't really put plan-driven versus Agile as some people are doing. Agile also has a planning dimension. It's much more that we focus on value and that we focus on the business perspective. And this is why we put this in this upper left corner, because that's a very important aspect in implementing Agile system engineering. Obviously, we have technology elements. Frank mentioned already the need for functional safety, the need for the new technologies. We work very fast into adaptive service-oriented architecture. We have a lot of legacy in different elements, heterogeneous tools, heterogeneous platforms, heterogeneous software, which we somehow have to evolve. We cannot simply switch from today to tomorrow without a transition. And this is also why we need a good process, because after all, what we are doing are safety critical systems, systems which are prone to an increasing amount of cybersecurity attacks. That means we have to mitigate risks and at the same time, being in a global competition, continuously improve our efficiency. And we do have governance because of the liability risk. With that, let me finalize this introduction with a typical Agile systems engineering transformation project. And the headline is already the major message, which is we talk here about a process. Agile is not an end, it's an evolution. And it's a continuous learning. And therefore, we perform retrospectives, for instance. It's often overlooked. People think, well, we take Agile out of a book. Well, there is no such book. I have customers which start with formal frameworks like SAFe or Scrum of Scrum and others, but at the end get stuck because these frameworks tend to get far too complex and still do not really apply to the specific situation. So an Agile transformation is really a transformation. I had this morning just a talk with a client, a CTO of a supplier, and he was very clearly saying the biggest need which we have today in our company is to create a software culture and understand software as being part of a system, but not software as an add-on to the hardware as we traditionally did. And this transformation in culture, in process, in competences, that's our focus.
Yeah, software is not even just a part of the system. It's maybe the driving element, and that's why the move into a more software-orientated world is so important. So I would like to share with you some insights into the transformation process we are in at BW. You saw on the page before that feature teams play a role, and subsequently, many years ago, the focus was to create a shift from a component-centric thinking, which, by the way, was exactly the same story in Ford, where I worked before, into a more feature and function-oriented work. On one hand, this is a result of distributed features and functions where you can't rely on component work only. So that evolution was done. It's based on feature dictionaries in the company so that you create a common language, and a rigor on good feature and functional specifications, functional realization specification, which implement the real design. And then the content is broken down to the components. All that's supported with roles in the organization, supporting templates to have really high-level quality requirements engineering, and as well, especially in a multi-brand organization, a group-wide harmonization of base technologies, which is a foundation to be able to exchange components and technologies in the part, was part of it. That was a good starting point, and I would call that already systems engineering, but we understood that the next step is really to move into an advanced level of systems engineering, which includes a few significant changes compared to what I shared before. The first important thing is that nowadays, and I mentioned it in the introduction, you need to consider cloud and the system of systems. The vehicle is not a product on its own, it's part of an ecosystem. That needs to be considered as the top layer in systems engineering. The vehicle as such is the second layer then, and below, it's not broken down into features and functions as such, but into main systems, subsystems, and from there down to a component level, probably with different or with dedicated hardware and software specs as own entity. In these system kind of level, the starting point will remain to be the requirements. What would you like to achieve? What is your customer expectation? And the derived requirements. But from there, we are using the RFLP approach to break down the requirements into functional aspects, which is similar to the world below, and to the feature orientation, and from there into a logical and physical world. So the process is structured, linked to architecture elements, and the link between requirements and architecture. I think that's a very important element. A robust handshake between those levels is key to success and required, for example, to fulfill ASPICE needs and to ensure that you have a robust design process. So that's the kind of transition we are currently in, and where we and how we are strengthening systems engineering. But the next way is to make that as well more agile. That is especially in BW now required, and it's getting easier because we work with Carriot as our in-house software team. They use a full agile approach in the PMT world, and as well in the way how they do the products. And linking to them is, of course, a key requirement for Volkswagen. Good. Christoph mentioned as well how important requirements are. Requirements are the starting point, and to be able to manage, even in an agile world, the complexity of products is that we remain to have a single source of truth, a very strict way to have a common structure and a data repository for all requirements. The agile way is that we baseline them more often. We can provide various levels of spec maturity to our supplier and partner, but they're all coming from a single source of truth. So that's a key value. Compliance is playing a big role in that area of requirements engineering, so that we know what are the legal obligations we need to fulfill. Common interfaces to our partners like Carriot and others are another key element, because of the data flow between all parties is easier than you, of course, create more speed and more transparency. The integration, especially in a joint tool world, which we are just working on, a data-driven tool approach is another element. And the link and the integration is key, especially on 3 areas I like to highlight here. One, the already mentioned link between architecture and requirements, because you derive the more detailed requirements from the architecture. So that's the leading element, it's architecture driven. But requirements nowadays are not only textual based, but as well model based. So we need to have that in mind, that we can combine textual requirements and model based requirements in a smart way. And testing is key, on one hand, to ensure quality, but agility means as well that you can have test driven approaches and so on. So having the close link between the requirements and the testing tools is what we are aiming for. Okay, how can agile systems engineering in practice look like? I think one of the key beliefs in the former times, when you had classical systems engineering waterfall approaches, was that you have a sequential design. You do your specs, hand them over to the supplier, they come back with a final product, you test it and do the final integration and then the release. Now we understand that this is not really the way to go, and probably has not worked for the last 20 years, because specs were not perfect, changes have to be made. So the concept to improve that is really to come from a solution train aspect, from a view that you have phases, which we already have seen in the past, I-series approach at VW, I think the ABC sample approach in the industry, as well as a phased approach. And agility gives us a freedom to enhance that, to say we start with a certain maturity of specification, a certain level of architecture and design, and bring that already to the supplier, get a first implementation done, so that we can really see the value growing over time and the product getting better. Those approaches with an agile release train, we believe are really required, and it will help as well, or the agile framework will help as well to do better planning with the supplier, especially the concept of PI plannings being done jointly, and to be able to share the progress over time is what we believe is very helpful.
And talking about traceability, we wanted just to emphasize one perspective, which is traceability model is necessary in order to make and facilitate traceability across heterogeneous tools, which is still very common in most companies. It's rare that you have one single tool chain, and it means we need this information model, the traceability model, across abstraction levels and across artifact levels, in order to, for instance, make a consistent safety case, to make a consistent security case, but very simply speaking, also to make sure that we have completeness with respect to our test strategy. And agile safety is currently a very big challenge in practice, because the faster we have these delivery cycles, and we speak here about continuous X, that means not only a continuous build, but also continuous integration, continuous deployment, eventually DevOps, means that we have in this flexible architecture still a need for fulfilling ISO 26262, for instance, as a requirement for a consistent safety case. And that also needs new methods based on traceability, based on a good systems engineering understanding to achieve consistency in terms of functional safety. And that brings us to the summary and outlook. Frank?
Yeah, so the growth of functionality and complexity will continue. We are not in a stable situation. We are still innovative and will see many changes. So I strongly believe that system engineering is the fundament of structured work, of a structured way to work, but that agility will help us to handle the uncertainty and to ensure that we have a faster and better software development. I think in the OEM world, speaking for more than one company, I think the concept for agile system engineering is required, and there are already activities, for example, in the VDA, to talk about how can we achieve that, how can we ease the collaboration between OEMs and supplier. 4 dimensions, as Christoph alluded to, are key. People with skill aspects, with culture and organization. I think it's very important that the cultural change is a part of agility. It's not just a new process framework. That's really important. Processes need to be improved to create more efficiency and transparency, which is a key agile value for me, and a clear and defined interface to the software world. That's where the make or break happens. Technology with more focus on model-based system engineering in a consistent way, and architecture-driven designs. And of course, from the business side, we need to focus on the value, bringing the value to the customer and quality. BW, as briefly alluded, is evolving the development framework to strengthen both system engineering and utilize agile principles, and to strengthen the interface and the processes with CARIAD as our in-house partner for the software design and for E/E technologies. And overall, I think, speaking for the industry, I think agile collaboration between OEM and suppliers is an area which will continue to be important, which remains to be an opportunity. And as Christoph's example from a supplier showed, that's really where we are sensing strong interest, and where I think we need to continue to have a dialogue in the industry, how we all can utilize the collaboration in the best way. With that, thanks a lot for your attention.
Thank you all for listening in. And well, sometimes I'm asked what competence would be necessary in the future. Following what Frank just said, it's really about a systems competence in respect to understanding how to model, how to build systems, how to break down system components, but also for those of you who come from embedded, it's important to get familiar with the classic, what we call IT or cloud related environment, vice versa. For those who come from computer science, that you get into embedded, because we see this convergence of product IT and enterprise IT, and that will further accelerate the software in our various companies, both OEM and Tier 1. Thank you very much, and contact us with any further questions.